Writing simple code is complex. We have a requirement to implement a new feature. We design and develop the feature. We created the unit, integration, and automation tests, and developed the scripts to deploy our new microservice. After reviewing the code, we realized that very few lines are related to the feature we implemented. Most of our code concerns hosting, communication, logging, error handling, housekeeping, and testing. Implementing a software system is complex, and building a microservices-based solution is much more challenging. In a distributed system, we raise the complexity bar to gain scale and resiliency. We pay with the effort required to maintain state consistency. We can use distributed frameworks such as Dapr, Distributed Application Runtime, to reduce the bar a little bit. While microservices empower developers with flexibility, isolation, and scalability, they also introduce the complexity of maintaining state consistency. A transaction spanning multiple services needs to either ultimately succeed or leave the system in a state as if it never happened. Here's the problem. How do you maintain consistency without compromising the autonomy of separate services? Orchestrating microservices with the Saga pattern. The Saga pattern provides a solution to this challenge. It enables multiple local transactions to run across services, where each transaction changes the state and initiates the next step. If something goes wrong, compensating transactions ensure the system returns to a consistent state. However, it's important to note that the Saga pattern is only the start, the what and why of distributed transaction management. The how, or the actual implementation, needs a reliable framework that considers the complexities of microservices. Enter Dapr, or Distributed Application Runtime, a portable, event-driven runtime that simplifies building resilient, stateful microservice applications. Dapr offers built-in features for state management, service invocation, pub/sub messaging, and more, which are instrumental in managing the complexity of distributed systems.